Let me know if you can see the PDF file with our Nielsen textbook, our reading material. So in the previous classes, particularly in the last class before the test, we discussed the problem of rate of change in various types of function. Here you can see examples that we covered in the last class, I believe. Yep, with this problem with beakers, where we were discussing how the speed of filling up the beaker changes with respect to time. And the main summary of that class was, first of all, that there are intervals of function where the function is increasing, as in the following image. Also, this is example of function that is increasing when we read from left to right. Here's the example of function that is decreasing from left to right. And finally, function that it is has no change with respect to time. So rate of change is constant and equals to 0 if the graph is just a horizontal line. And this is very important. So remember that the formula for rate of change is delta y over delta x, which equals y2 minus y1 over x2 minus x1. And when this equation equals 0, it means our graph turns into a horizontal line. Or there is another scenario when this rate of change equals to 0. Remember that if we evaluate the instantaneous rate of change in some specific point, right? Using different methods of shrinking, intervals, etc., which we also discovered in previous class, we can also study the quadratic function. And you know that quadratic function has a vertex on its highest point or its lowest point if parabola is upside down. And instantaneous rate of change to this graph at this point of a vertex, the highest point of the curve, the instantaneous rate of change equals 0. This formula for average rate of change also equivalent for instantaneous rate of change. And we can also call this ratio as m, tangent of an angle. Tangent of this angle equals 0, which means this is a horizontal line touching the curve in this point. This is what we're going to discuss more deeply in today's class. Also, you have to remember that there are intervals where the speed is increasing. You see the angle becomes more and more steeper with respect to time. And here on the opposite, the graph becomes increasing slower and slower with respect to time because angle is decreasing. Angle of this tangent line to the curve, right? Or you can do the same stuff using the average rate of change between 2 points. Realistically, you're going to get pretty much the same result as using instantaneous rate of change. But remember, average rate of change shows the average change between 2 points, and instantaneous rate of change shows the change of the function in specific point. Okay? So what we're going to do today is we're going to jump into solving problems involving rates of change, because this is really important for our next chapter that we're going to start, which is polynomial functions. In polynomial functions, using your rate of change techniques will be really useful in order to evaluate properties of polynomial functions. Please take a moment to look at what you're seeing on the screen. And I would like to ask each one of you to do a practice problem just to remember how to work with average rate of change function. Delta y over delta x, this is what you're going to use. And question A, calculate the average rate of change in profit for each interval of ticket price. Here is the problem. A theater company profit, P of x, in dollars, is described by the equation P of x, which is function of profit, equals negative 60x squared plus 1800x plus 16,500, where x is the cost of a ticket in dollars. Okay, so x in this function is the cost of a ticket. You can name it as C, cost, and calculate the average rate of change in profit for each interval of ticket prices. So from 12 to 15. Let's say if this graph looks as follows, if this is my coordinate axis, first of all, later we're gonna learn about characteristics, and this parabola is gonna be turned upside down because we have minus in front of the leading coefficient. This is what we're gonna learn as well. So this function should look like this, something like this. I'm not sure how is it located in 4 quadrants, but it's gonna have this following shape of upside down parabola. And let's say this is the x-axis, this is y-axis. Y-axis stands for profit of the company, and x-axis represents for the cost of a ticket, right? Cost of ticket. And we have to calculate the average rate of change between points 12 and 15. Let's say they were positioned as so. So this is one point on the graph. This is the other point on the graph. And we have to calculate the average rate of change between these 2 points. I just gotta make sure, guys, that everyone understands how to do this. This is why your first task for today, each one of you, Ahmad, you do 12 to 15, your letter A in front of it. Hala, you do 15 to 17. Muhammad, you do 15 to 15.2. And Safa, you do 14.8 to 15. Okay? Let's do it together, guys. Let's work together so we can cover more material together. I'm telling you, you would like to have extra time by the end of the course if we move in a decent pace. And I need you to work together with me in order to be successful, okay? Please, it's not a long, it doesn't take much time for you to do this, okay? Do you understand the assignment? This is your function. And you have to calculate the average rate of change between points 12, 15, 14.8, 15, 15 and 15.2, and take it notice that one point is common for all of them. Ahmad, Hala, Mohammed, Safa, please let me know that you understand the assignment and you're doing it.
Yeah.
I just have a quick question.
Yep.
So basically, for this one, for like my question, I need to find the x values between, sorry, greater than or equal to 15 and
No.
less than or equal to 15.2, and then numbers
So
in
as I,
between that.
yeah, I understand your question. So as I understand, you missed the previous classes, right?
Yeah.
So what we're going to use here is an, can you turn off your mic, please? Thank you. So what we're going to use for solving this problem is an average rate of change function. What is an average rate of change function? Let's say from point A to point B, you have certain speed, right? In point A and point B, and you have with respect to certain time. For example, at start of your road, you were going this fast, and then you increase your speed this much with respect to time. You have delta t and you have delta v, change in your speed, for example. You can replace these variables with delta y or delta x. It's not crucial here, it's just the numbers, okay? So, for example, in point A, you had speed 10 kilometers per hour. In point B, you have speed 20 kilometers per hour. In point A, it was 1 second after you started driving. In point B, it was 2 seconds after you started driving. So using the average rate of change function delta y over delta x, change in y-axis with respect to change in x-axis. Delta means change, okay? Delta y and delta x equals y2 minus y1. So value in the second point minus value in the first point exactly gonna give us this change, right? This change in y-axis, you see? Change between value in point B and point A. So y2 minus y1. And for denominator, we're gonna have to take x2 minus x1, change in x value. Here, x was 1 second, x2 is 2 seconds. So delta x, this interval, equals 1 second. Do you agree with me? So this is what an average rate of change function. And you have to implement it for this problem. In this problem, you have certain formula which represents your y value, isn't it? So if you substitute your x values into this formula, you're gonna get your y value. So what you have to do, you have to find y2 value in the second point, and y1 value in the first point. For example, for Muhammad, 15, this is your problem, from 15 to 15.2. So first x1 equals 15 for you. x2 equals 15.2. These are 2 points that you're investigating. Between these 2 points, you're calculating the average rate of change. So what you need to find is y1 value and y2 value for the following x values. If you don't understand it, I can repeat it again. Just let me know. So in your example, you have to find this function. Let's denote this function as y. You have to find delta y over delta x equals y2 minus y1 divided by x2 minus x1, which is equals to x2 equals 15.2. So 15.2, subtract x1. x1 equals 15. This is your denominator. And what is in your numerator? In your numerator, you have y2 minus y1. What is y2? y2 is this function with x2 value. So negative 60 times x squared. But this x, you have to substitute x2. x2 is 15.2. So what you have here is 15.2 squared plus 1800 times 15.2 plus 16,500. And now you have to substitute y1. And what is y1 value? y1 is this function with x1 value. So you say minus. Don't forget to put a bracket here because you're substituting like all of this together from the left hand side. So you have negative 60 times 15 squared, etc. and so on, so on. Finish up with this function and then calculate the value, and you're gonna find the average rate of change between these 2 points. Do you have any questions? Yes, absolutely right. You do the same for x1 and x2, and then you use those y1, y2, x1, x2 values in this formula, y2 minus y1 divided by x2 minus x1. As soon as you miss the previous classes, you may not know that this ratio, if you look into this function right here on your right-hand side, for example, between these 2 points, 12 and 15, y2 minus y1 divided by x2 minus x1 will give us a tangent of this angle of the slope. this would be the tangent value of this angle. y1 divided y2 minus y1 divided by x2 minus x1. Because this is your delta y and this is your delta x. And what is in this triangle that we are getting here? Delta y divided by delta x. This is exactly tangent of this angle. Opposite side divided by the adjacent side. So basically tangent equivalent to the average rate of change. Okay, guys, I hope I explained this problem pretty well, and I want you to solve one example for each one of you. Hala, Safa, Muhammad, Ahmad, I need you to confirm that you understand the task.
Yeah, I have a question
Yes.
for you put like 60 times 15.2 squared plus 1800, and then you did times 15.2 again. Were you meant to put 15 instead of 0.2 after the 1800 times?
So what I'm doing here is that I'm substituting x2 value into my function, right? My function is as follows: negative 60 times x squared plus 1800 times x plus 16,500. So I have to substitute my x2 here after 1800 and my x2 here after negative 60. This is for my y2 value. For my y1 value, I would substitute x1 after 1800 and x1 after negative 60. Does it answers your question?
Yeah, thank you.
Yeah, no problem. Thank you for question. So basically, at the end, what you're gonna get in your nominator, I'm gonna clear the desk a little bit. Yep. At the very end, what you're gonna get? You're gonna get a fracture, right? Delta x over delta y. In your nominator, you're gonna have this function from basically p of x2 subtract p of x1. In this way, it's more compact to explain it like this. So in your nominator, you're going to get p of x2 minus p of x1. I believe you should know what it means. If you write your function like this, it means that your variable in this function takes value of x2. And in denominator, you're going to have x2 minus x1. This is your final form for average rate of change. And each one of you basically should solve it for pair of 2 points. And then we're going to compare your results and we're going to see some interesting tendencies. Let me know once you finish. Okay, guys, any progress? I see Hala got negative 120. So basically, Hala's result means that from an interval from 15 to 17, our function is decreasing, right? If the average rate of change is negative, it means that the tangent line is going to be like this, looking down, right? The angle is going to be negative. Do you agree with me, Hala? Negative 120 means negative slope. So interval from 15 to 17, function is decreasing. Okay. And I'm pretty sure on interval from 15 to 16, it will be decreasing as well, right? Because 15 to 16 is part of 15 to 17. And unfortunately, I think Ahmad is not really active. So what his result would show us that on interval from 12 to 15, the function is increasing at the rate of 120. So it would be increasing to 120, 120 positive, while here we have 120 negative. This is first interesting observation. So it means basically points 12 and 17 supposed to be equally somehow positioned away from 15. Sorry, I think I'm mistaken. It won't be 120 positive. It would be just positive value, because eventually what's Muhammad's and Safa's calculation would show us that the closer you get to 15, so the smaller you make the step. So for example, if we get closer and closer to this point from both sides, you're gonna see that when x equals 15, the slope of a tangent line equals 0. And we just sorry, Safa got negative 24,000. I believe you made a calculation mistake somewhere. So basically what we're going to see here is that when this function has x equals 15, or basically price for ticket gonna be $15 per ticket, our function reaches its local maximum, right? You see this parabola is upside down. Hala, sorry, I don't understand. I have to calculate it to know exactly how much it is. If you made this algorithm correctly, you should get a correct answer. But I know for sure, because I calculated this before, that 15 is going to be a local maximum of this function. So basically, slope of a tangent line equals to 0, right? The tangent line is horizontal. This is maximum value. Imagine if you were climbing a hill and this is the highest point that you can reach. After this point, hill going down. So before this point, hill going up. After this point, hill going down, which means that function is increasing everywhere between before 15 and decreasing after 15. So basically it means that the maximum value that in this function that we can get is 15. So we are first characteristics of local maximum. This is what we're trying to investigate here. Local maximum of our function. First characteristic is that the rate of change in this point equals to 0. Why can we talk about instantaneous rate of change? Because in this example, so for Safa and Muhammad, what we're doing is basically using the shrinking interval method by getting closer and closer to value x equals 15. And this method gives us approximation of instantaneous rate of change. Yes, so Muhammad got -12. It means function is decreasing from 15 to 15.2. And Safa, we're supposed to get +12, which means function is increasing from 14.8 to 15. And basically what you can see here, 14.8 and 15.2 are equally spaced from 15, right? But in different directions. So quadratic function has such a beautiful property as symmetry over its vertex, right? So basically, in this example, our parabola would look in the following way. When x equals 15, we have our maximum, absolute maximum value. And parabola has a beautiful property of the symmetry over its y-axis. So parabola looks the same to the left and to the right-hand side from this axis of the symmetry. This axis of the symmetry goes through the maximum value of this function. So basically at point 14.8 to the left-hand side and in the point 15.2 to the right-hand side, we have equally spaced points, but in this case we are increasing. In the right-hand side, we're decreasing, going down already. Safa asking how would we calculate it? So exactly the same way as calculating average rate of change. One of the methods is by making the step in x-axis as small as possible. One of the points must be your point of interest, for example, 15. And what you're doing is by taking the second point as close as possible to 15. For example, 15.0001 would be even closer to 15 than 15.2. And by doing that, you're going to see that the average rate of change travels to 0 the closer you get to this point. That's one way of approximating the instantaneous rate of change. One more time, in the advanced functions, we only estimate instantaneous rate of change. In calculus, you learn how to calculate the exact value of instantaneous rate of change through derivatives, but we're not going to cover this in this course. Is there any more questions on how to solve this? How do we identify that x equals 15 is the maximum point of this graph? So we were asked to calculate the average rate of change in profit for each interval of ticket prices. And we calculated that the maximum profit will be when the price of the ticket is $15. So how could I know that this graph gonna look like this? I know it because I know characteristics of polynomial functions, which we're going to cover later. But also, you could make a statement that this graph should look like this by evaluating its average rate of change. Here, you can see that to the left-hand side from 15 function is increasing, and to the right-hand side from the 15 function is decreasing. How can you plot such parabola? Only curve that going up at the left-hand side, right? Because function is increasing, so our curve should go up. And on the right-hand side, function is decreasing, so the curve starts to going down, right? That's exactly what we covered in the previous class. This is what we started our class from. You see, these 4 types of a curve that can occur. So now we know first, function has maximum value, local maximum, when its rate of change equals to 0. If we are talking about polynomial functions and quadratic functions. In another case, if you have a linear function, if your average rate of change equals 0, it means your line is horizontal. So we cannot talk about local minimum or maximum, okay? It's only in respect to polynomial functions, quadratic functions, etc. First property of a maximum. Tangent of an instantaneous rate of change to this point equals 0. Second property. To the left-hand side, from this function and the right-hand side, average rate of change has opposite sign. If function before this point is increasing, that after this point it must be decreasing, because otherwise this wouldn't be a local maximum. Okay? So if first increasing, then it's supposed to be decreasing afterwards. If it's decreasing at the beginning, then it must increase afterwards. And in this case scenario, what you're going to get is a parabola that is looking upward like this. So it will be decreasing at first and increasing afterwards. This is talking about quadratic functions. Here, another example on how to use the average and instantaneous rate of change for solving problems. For example, here we have function of the height with respect to time, and we have to calculate that when leopard will be closest to the ground. So basically, if this function describes his height above the ground, then local minimum would give us closest point to the ground, right? We can see that this is a cosine function or trigonometric function, which looks as follows. It's periodic wave, like this, and if this wave describes height with respect to time, right, like this, then lowest point of this cosine function where tangent equals 0 would be the point that is closest to the ground. On the other side, these points on top would be points that are higher from the ground, so maximum value. These are maximum, and these are minimum, right? And Shrew thinks that the Leonard will be closest to the ground at 55 seconds. So what we gotta do is to, first of all, we have to identify whether this local minimum or local maximum 55. How can we do that? We examine the average rate of change before this point and after this point. If the average rate of change is decreasing before and increasing afterwards, so it's negative before and positive afterwards, it means it's minimum. On the other way, if the average rate of change is decreasing and then increasing, so the function is we're slowing down and then going even farther down, it means it's local maximum. Okay? And another thing, we have to check whether it's a special point or not, whether it's local minimum or maximum or not, by testing the instantaneous rate of change at this point, as we did in the previous example. What we did is by shrinking the interval from 50, for example, from x value that we're interested in, we took some value that is extremely close to our point of interest, and that's how we estimated the instantaneous rate of change. In this example, you can see that they took 2 points, time 54 seconds, and 56 seconds before and after moment in time 55 seconds. Basically, which gives us equally spaced intervals in front and behind these points. Result of this calculation shows that before this point, so from 54 seconds to 55 seconds, the average rate of change is negative, so function is decreasing. On the other hand, from 55 to 56 seconds, the average rate of change is positive, so function is increasing. Also, you can see that the value of the average rate of change is equal by its modular for both intervals, which means basically x equals 55 or time equals 55 gives us point of a symmetry, right? For local symmetry of the graph, which makes it point the minimum point of this curve. By substituting t equals 55 into the formula, we're going to see that the height equals to 1 meter. And before this, at point of time 54 seconds, height is 1 meter and 12 thousandths of a meter above the ground, as well as at point of time 56 seconds, it will be the same height above the ground. So moment in time 55 seconds is the indeed lowest point above the ground. Since the rate of change is since the rate of change in height using a point to the left of t equals 55 seconds is negative, and using a point to the right of t equals 55 seconds is positive, and since both are close to zero, the instantaneous rate of change could be zero at t equals 55 seconds. Since the estimate of the instantaneous rate of change at 55 seconds is zero, and since height at 55 seconds is less than both at 54 and 56 seconds, Leonard is closest to the ground at 55 seconds, just as Shu predicted. So now again, we're using the properties of local minimum and maximum to solve real-life problems. Is there any questions on how this problem can be solved? Okay, so please take a moment to copy down the solution for your further reference. And I suggest you make a 10 minutes break because we're already 40 minutes into the class. Okay, just stretch your legs, stretch your arms, drop down the pen and relax for 10 minutes, and we're gonna get back at 6 and 5 minutes, 5 after 6. Okay, guys, I'm back. Is everybody with me? Are we ready to continue? Yep. Okay, great. So let's take a look at the next example. So what it tells us that we're going to investigate how to select a strategy, algebraic strategy, to identify the location of a minimum value. Okay? So question says, show that the minimum value for the function, quadratic function x squared plus 4x minus 21, happens when x equals -2. So we know that this is parabola, and because the leading coefficient is positive, it's going to be parabola looking upwards like this. And show that the minimum value for the function x squared plus, oh, sorry. So because it's positive, it's going to look like this, right? Facing upwards. Show that the minimum value of this function occurs when x equals -2. And we already know several techniques on how to estimate the average and instantaneous rate of change. And one of the best way, as I see it, is by traveling delta x change of the independent variable, delta x. Travel it to 0. What it means? As in previous example, we did like 15.1 and 15.0001 second point. As you travel delta x to 0, basically what we're saying is that x2 minus x1 travels to 0, extremely small number. And let's call this extremely small number h, okay? So basically in our delta y over delta x function, we replace delta x with h. So what we get? On top we get f o x2 minus f o x1 divided by h, this very small number, right? So estimate the slope of a tangent to the curve when a equals -2 by writing an equation for the slope of any second line on the graph of f of x. Basically, we're writing our standard average rate of change function, but now we use method where delta x travels to 0 or equals h value. Here is basically what we're gonna get, right? F O x2, and x2 is x1 plus h. x1 equals -2, so -2 plus h. Function from -2 plus h minus function from x1. x1 is -2, right? Now we have to substitute -2 plus h into our parent function instead of x. So how are we calculating it? X squared will turn into -2 plus h squared, plus 4x will turn into plus 4 times -2 plus h, minus 21, right? And x and y of x1, f of -2, will be -2 squared plus 4 times -2 minus 21. And this will be equal to -25, as we can see here. So remember that the right-hand side, so f o x1, you should treat it as a brackets, because you subtract this whole expression from this expression. So we have brackets here, and minus -25 will give us plus 25 basically, right? Minus and minus gives us plus. Then by simplifying, opening these brackets, you know how to calculate the perfect square, and opening all of these brackets would give us the following expression with h in it. Now the next step is to simplify it by choosing the common terms. For example, 4 minus 8 plus 4, negative 4h plus 4h, and just h squared, right? We group up terms with the same power of the exponent. So after simplifying, 4 plus 4 is 8 minus 8 is 0, minus 4h plus 4h is 0, so all we left behind is h squared over h. Now, at this stage, we can factor h out as so, and answer is h, right? This is our answer for average rate of change, or approximation of the instantaneous rate of change. So remember what we said at the very beginning, that h is extremely small number. So the smaller we take this h, or the smaller we take delta x, then closer we will be to estimating the instantaneous rate of change, right? The closer we get to this single point, the higher the accuracy of the estimation of the instantaneous rate of change. And you can see if we take h 0.01, we get a rate of change of negative 0.01. If we take positive value, it will be positive, so and so on. And since the slope of a tangent is close to 0, there could be a minimum value at x negative 2. So once again, to estimate the slope of a tangent at x equals negative 2, use 2 points and the difference coefficient. So this method is called difference coefficient. H is a difference coefficient. For 1 point, use negative 2 and negative 25, which respects to x1 value, the point where you want the tangent line to be, okay? x1 is point where you want the tangent line to be. For the other point, use the general point on the graph of f of x, for example, x1 plus h. So basically x1 plus delta x. And f of x1 plus delta x. This is notation for general point on the graph, right? The starting point plus some step. In this way, we can express any point on the graph. Okay, and since the slope of the tangent occurred to be close to 0 from both sides, there could be a minimum value at x equals negative 2. Now, next step, take the average of these rates of change to improve your estimate of the instantaneous rate of change at x equals negative 2, right? We take the average rate of change to the left, to the right, and finding its average would give us a higher estimate, because basically we're estimating something in between of those 2 points. And here, result would give us 0. So our estimated instantaneous rate of change when x equals negative 2 equals to 0, so this could be a local minimum. We use 2 values of x that are close to negative 2 but on opposite sides of it to calculate values for the function. Compare these values for the function to the value of x equals negative 2. And in fact, you can see that on both sides when x equals negative 2, we have greater value than when x equals negative 2. In fact, x equals negative 2 is the minimum point of our parabola or our quadratic function that we're studying. Since the slope of the tangent is equals to 0 when x equals negative 2, and since the values of the function when x equals negative 2.1 and x equals negative 1.9 are greater than the value when x equals negative 2, a minimum value occurs at x negative 2. Remember, x negative 2 is the line of symmetry for our parabola, so equal step to the left and right should give us same result for the average rate of change by modula, but different in their sign, because here we're going to have a negative angle and here we're going to have a positive one. Any questions about this? Any questions about that, how to use the difference coefficient to estimate the instantaneous rate of change? So this is very important technique, because later on you're going to see that many polynomial functions have much more than one maximum or minimum value, and using this technique will help you to evaluate this minimum and maximum points. Any questions? Okay. Take a moment to copy down this solution with difference coefficient, okay? Let me know once you finish. It's really important to keep it by your side. How's it going, guys? Did you copy this solution down? Okay, great. I believe I gave you enough time to copy it down. We're gonna skip this example with graphical calculator, but the graphical calculator are using the same method, basically, by approximating closer and closer to the point of interest. And let's summarize what we actually learned today. Key ideas is that the instantaneous rate of change is zero at both maximum and minimum points. It is very important to understand that rate of change is going to be zero in both of these points. As a result, the tangent lines drawn at these points will be horizontal lines. Okay? What you need to know, if the instantaneous rate of change is negative before the value where the rate of change is zero and positive after this value, then a minimum occurs. Graphically, the tangent line must have a negative slope before the minimum point and positive slope after. If the instantaneous rate of change is positive before the value where the rate of change is zero and negative after this value, then a maximum occurs. Graphically, the tangent line must have a positive slope before the maximum point and a negative slope after the point. Remember when we were discussing on how to understand whether this point minimum or maximum or not. Instantaneous rate of change before negative, positive afterwards, it's minimum. If it's positive before and negative afterwards, then it's maximum, right? Going down, then going up, minimum. Going up, then going down, maximum. Must be pretty much like intuitively understandable at this stage. Okay? And now let's do a little practice here. Then we have another half an hour left, and I suggest that we do a little practice exercise together, and you can ask any questions that you have, because this is crucial, because you can see in next class we're starting polynomial functions, which is a really important chapter of all of them. So difference coefficient is the following formula, copying down. F of A plus H minus F of A divided by H, where A is the point that we are interested in. In this point, we would like to find the instantaneous rate of change. Okay? And let's do a little practice together. Let's do exercise number 6. Use an algebraic strategy to verify that the point given for each function is either a maximum or a minimum. So what do we have to do? First of all, we have to show that it's really minimum or maximum by calculating its difference coefficient, right? Instantaneous rate of change at this point, FOA plus H minus FOA divided by H. Here, A point has coordinates 2 in X, right? 2 and 1 in Y. When X equals 2, Y equals 1. So this is first step. You have to show that this equals to 0, in fact. Then you have to check whether before or after this point an instantaneous rate of change positive or negative. So what you're doing, you're taking one point before. So for example, when X equals 1, X equals 2 is our point of interest, right? And X equals 3 would be point after. You check the instantaneous rate of change positive or negative here, positive or negative here. If it's negative, then positive. It means this is going to be a local minimum. If it's positive, then negative, it means it's local maximum. Okay, I want you to practice this to make sure that you understand this for 100%. So, Hala, please do example number A. Safa, please do example number, okay, B looks complicated. Do C for Safa. Rest of you guys, Muhammad, try to do E. Rana, try to do F. Okay? And then we're going to compare our answers and see if anybody has any problem with this. Because this is, guys, I'm not doing this because I just want you to solve these problems. No, I'm doing this because on this method of difference coefficient, most of your future calculations are based. If you understand it clearly now, later it's going to be much easier for you, okay? Please do your assigned task, and I'm waiting for your solutions here. If possible, you write whether it's local minimum or maximum, and write why is this local minimum and this local maximum. Okay, Hala. But you are not supposed to use the derivatives method. We are not studying derivative method in advanced function class. In this class, we covered shrinking interval method and the difference coefficient method. And for you, Hala, yeah, you're right. Your function is concave up. Also, this parabola is going to be like this. So it means that your leading coefficient is positive. No worries. It's good that you know derivatives. And basically what we're doing right now is basically derivatives, right? But derivatives is another approach to this same problem of limits, right? Of this rates of change. Basically, average rate of change is equivalent to the derivative of a function. But we are not using derivatives yet. Okay, Safa, this is minimum, right? Your function is also parabola that is concave up because leading coefficient is positive. Wait, you're saying that your minimum is at point x equals 6? C is a minimum when x equals 6, not 4.5. Yes, derivatives are summary of all of these properties that we're studying right now, but used as with a generalization to various type of functions. Derivatives, there are rules for derivatives for all types of functions, but average rate of change is um, the average rate of change can be used as a method for any type of function. You don't need specific rules for other types of function with average rate of change. Sorry, Safa, I don't really understand what you're saying. C is a minimum point, in fact, because parabola is concave up. So what you're saying that, okay, so what you're saying that average rate of change is 23.75 when x equals 4.5, right? So 4.5 is not minimum value. There is another minimum value which you discovered as 6, right? Okay, I see. That's good. That's good. So if you do that, if you try to do the interval method with 4.5, so what you do, you take 4.5 to the right hand side, for example, you take 4.6, to the left hand side, you take 4.4. And what you're going to see that if 4.5 is not local minimum, first of all, your instantaneous rate of change won't be 0. And secondly, before and after this point, function would behave in the same way. For example, if you say that 6 is your minimum point, then before 6, function is decreasing. So it will be minus from 4.4 to 4.5, and it will be minus from 4.5 to 4.6. Is that what you get, Safa? Great, great, good job. And one more thing, Hala, make sure to use difference coefficient method when solving your problems in tests, etc. Don't use derivatives. Of course, you can use derivatives for your convenience to check if your calculator is right or not. For question E, would it be a minimum? So in question E, we can see that this is not a quadratic function. It's cubic function. It has third power. And it's hard to say whether it's minimum and maximum right away because cubic function is going to have two maximum and minimum. So cubic function looks like this. Maximum, minimum. And to check whether it's minimum or minimum or maximum, what you have to do is to take point to the left from x equals -1 and to the right from x equals -1. So one point you take x equals -2, the other point you take x equals 0, for example. And you evaluate the average rate of change between x -1, -2, x -1 and 0, and you see if it's positive before and negative afterwards, it means it's maximum value. If it's negative before and positive afterwards, then it's minimum value. Okay? So what you check? You check m, the tangent of a slope, y2 minus y1, divided by x2 minus x1. x1 for you is, in first scenario, is -2, and x2 is -1. So you substitute -1 and -2 into y2 and y1. You calculate this value. You check whether it's positive or negative. Let's see. If x, -2 and -1 delta x is positive actually. So it's gonna be 1 in denominator, and nominator is gonna be to the third power, so minus 1 to the third power is negative 1 plus 3, so it's positive, plus negative minus y1. y1 x equals negative 2, so negative here, negative 2 to the power 3 is negative 8. So this is negative, but altogether it's positive. So it's positive before and after. If we substitute 0 instead of one of the x's, we're gonna get delta 1 again, but y2 equals 0 and y1 equals positive plus 2. So it's positive afterwards. So basically, it's positive afterwards and it's negative before, which means if it's positive after and negative before, it means this is local minimum value. You're right, Mohammed. This is going to be a minimum value. Do you have any questions on how do we estimate whether it's minimum or not? Okay, good. So now, good job, guys. I appreciate your work. You did really good job. And now I'm going to select a few exercises for you as your home assignment. It's going to be a few basically problems where you have to figure out how to use instantaneous and average rate of change. Altogether, you're going to have 4 problems to solve. Okay, great. Now I'm going to post these assignments to your Google Classroom. I remind you guys that doing your home assignment is crucial because if you're looking for a good mark, you have to submit your home assignments as soon as home assignments value quite a few points from your final evaluation. Okay, guys, I've posted the home assignment. You can check it out right now. So, Hala, you have to use the following methods. First of all is shrinking interval method. Whether the second method is difference coefficient. These are two main methods of estimating the instantaneous rate of change. Shrinking interval method and difference coefficient method. Okay? Difference coefficient method and shrinking interval method. No worries, Hala, it's easy. So you're basically looking into delta y over delta x formulas. Delta y over delta x. Okay, guys, do you have any more questions to me? Well, we're still here. Okay, great, Mohammed. Thank you for your work today. Good job. Keep up. And we're going to post our recordings of previous classes so you can review them. Please follow up with our YouTube channel, and latest tomorrow you're gonna see new videos there, okay? Okay, guys, good job. Work on your home assignment, and in case of any questions appearing, feel free to contact me and consult. Thank you for the class, everybody. Have a great evening, and looking forward to see you on Friday. Bye-bye.